Hi there, Mr. Sutton with the Pre-Cal Honors 4-7 Part 2 homework solutions on applications of exponential equations. For this problem, we have a savings account compounded continuously. If the interest rate's 2.8% per year and our current balance is this, we want to know in how many years the balance will reach 2287.57. Okay, so we've got continuous compounding, so let's start with the PERT formula, and let's plug in what we can here. We're starting with a principal of 1,793. That's our starting amount for P. E is just E. R is our interest rate. That's going to be 0.028. Time we're looking for, so we'll leave that as a T. F of T, that's our target amount of $2,287.57. So there's our initial setup for this equation. Now we just have to solve for T. So to do that, we isolate the exponential term. So dividing both sides by 1793. And at this point now, to get this variable out of the exponent, we have to take the log of both sides. Since I've got e in this problem, I'm going to take the ln of both sides. So when I pop out this 0.028t, I'm going to have ln of e next to it. But the ln of e is just 1. So on the right side, then I've just got 0.028t. And on the left side, I'm logging this whole thing here. Now I just have to divide both sides by 0.028 to get t by itself. And at this point, I'm actually going to use my calculator and figure out what this number is. So to do this, I'm going to do alpha y equals and use my fancy fraction. Then I've got ln of fancy fraction 2287.57, and we'll divide that by 1793 and close the parentheses. Below, I just have 0.028, all of that equaling about 8.70 if I round it to 2 decimal places, and that's going to be in years. For this problem, the made-up element openarium has a half-life of 5 minutes. How long will it take this isotope to decay to 78 kilograms if we start with 365 kilograms of it? So we're going to use the half-life formula, f of t equals ab to the t over k. Our target amount, f of t, is going to be this 78 that we want our openarium to decay to. A is going to be our starting amount of 365. Since this is half-life, our b value is going to be 1/2 or 0.5. T we're trying to solve for, and k is our half-life of 5 minutes. So here's our setup. Let's go ahead now and isolate the exponential term so we can take a log of both sides. Dividing both sides by 365, we've got 78 over 365, whatever that comes out to. Now I'm going to log both sides. So I've got log of 78 over 365 equals, and now our exponent pops out. This is t over 5 times the log of 0.5. Now to get t by itself, I have to multiply by 5 over here and divide by log of 0.5. So I'm going to have t equals 5 log of all this stuff divided by log of 0.5. And at this point, I'm going to use my calculator. So here's what I'm entering in my calculator. And I used alpha y equals to get this fancy fraction formatting. Makes it a lot easier to look at and keep track of what I'm doing. Pressing enter, I get 11.13. And this was in minutes. So there we go. On this problem, we have an investment made at 7% annual interest compounded daily, so that's going to complicate things a little bit. How long does it take to triple the investment? So we're going to start with the formula f of t equals pb to the t. Next, since I'm compounding daily, I need to come up with a b value that lets me do that. So I'm going to use my formula of 1 plus r over k to the k. In this case, we have an r value of 0.07 for the interest rate, a k value of 365 because we're compounding daily, 365 times a year. So here's that setup. 1 plus 0.07 over 365, all raised to the 365. Let me do that on the calculator. So I've entered all that on the calculator, and I'm going to store that. I pressed the stow button and then alpha A right here, alpha math, to give me A. I'm going to store all that as the value A. I'm going to write it down here as well, but I want to actually use the true value when I calculate all this out later on. But here's what I'm just going to represent that with for now. Now I have to actually plug some things in here. So I just found approximately what my b value is. t we're going to leave there because we're solving for time. We want to know how long it takes to triple. But now what should I put in for my principal and my target amount? Because they never told me what the initial amount is. But they did tell me that I want 3 times that initial amount. So I'm going to leave p here. For f of t, I'm going to use 3p. And if you really wanted to, you could make up a number for p and then put 3 times that over here. But it comes out to the same thing. Because to solve this, we have to divide by the principal to get the exponential term by itself. So we end up with 3 equals 1.0725 to the t. And at this point, I have to take the log of both sides. So I've got log of 3 equals t log of 1.0725. To find the time, I now have to divide log of 3 by log of all that stuff. And now I have to use the calculator again. Now when I'm doing this on the calculator, I've got log of 3, and remember that I stored this crazy decimal as a. So I'm just going to divide by the log of a, and that'll give me the most accurate answer possible, which is going to be 15.70 if I round it to 2 decimal places, and that's going to be in years. For this problem, during the exponential phase, we have some E. coli bacteria increasing at an exponential rate. If the growth rate is 2.6 per minute and the current population is 139 million, in how many minutes will the population reach 167.2 million? All right, so for my general setup, since I'm just doing a growth rate of 2.6% per minute, I don't need anything special. I'm just going to use my AB to the T formula here. For my target amount, my F of T, that's this 167.2 million. For my A value, my initial amount, that's the 139 million. And I'm just going to write all of this without the millions. We'll just, because we're using millions in both places, so it'll take care of itself in terms of canceling those out. Next, for my B value, that's going to be, let's see, our growth rate is 2.6%. So my B value then is 1.026. And we're looking for t, so we'll leave that untouched. Now let's go ahead and solve for t. That'll be 167.2 over 139 for my first step, so I can isolate that exponential term. Next, let's take the log of both sides. So log of all this stuff equals t log of 1.026 using my pop-out rule. Next, let's divide log of that stuff by log of 1.026 to get t by itself. And at this point, I really do need to use the calculator. Here's what I've entered in the calculator. If you're wondering how I got the fancy fraction, that was alpha y equals and then n over d. So we've got log of my fraction there over log of my growth factor equals 7.20 if we round it to 2 decimals. And that was going to be in minutes.